No, I'm not taking this. I was going to, but just not going to. All right. The final identity that we are going to be looking at before we start working with kind of solving some of these equations is going to be our half angle identity. So we looked at the double angle yesterday, which was essentially just a kind of glorified version of the sum and difference formula, really the sum formula there. These are pretty disconnected from anything. I'm not going to go through any kind of derivation for this. And to be entirely frank, this is kind of the quintessential example of like what you could reasonably expect to be given on, say, like hypothetically a test that you guys had on like Thursday or something crazy. This is, I mean, ultimately it's not particularly difficult conceptually. We are just plugging into formulas. We'll see there are a couple of pieces here that can be a little bit tricky. In particular, the angles that we will be given are not necessarily the angles that we are working with, which is kind of one level of difficulty here. And we'll see that kind of at play here. The other thing that I want to kind of highlight that is different about what we see is the presence of this plus or minus, which we haven't ever really had to deal with up until this stage. In particular, we're going to see that this kind of is, again, where the difficulty is located, the idea of the fact that the angle that we are taking the trig function of not being reflected in the angle that we are actually processing, in the theta that we are actually processing here. But the utility here is pretty similar to what we have seen with kind of our double angle with our sum and difference. It's all the ability to kind of take information that we do not know, information that is not a part of what we kind of have learned from the unit circle, and to reformat such information so that we can process it as if it was unit circle information. So looking, for instance, at example 4 here, we are trying to find sine of 67.5 degrees. Now, does 67.5 degrees, is that something that we have unit circle knowledge about? No. Can we decompose this into the sum of two angles that we already know? No, we're going to have trouble with that as well. That 0.5 ends up being pretty tricky for that. Also, just the 7 as well is not something that is going to be particularly easy for that. And so we are instead going to try and figure out what is a theta that we can use. We can represent this kind of 67.5 as an angle that we do know, some kind of unit circle angle that we do know, divided by 2. How can I rewrite sine of 67.5 degrees here? 135 over 2 degrees. Yeah. Oh, it's cosine? My bad. Yeah, sine is we'll do the radian one in sine. Same idea though. Writing this as 135 degrees over 2. All right, so formatting this again so that we are taking the actual kind of cosine of the angle we know, this is going to be using our half angle identity here, plus or minus the square root of 1 plus cosine of this 135, all divided by 2. So notice that the theta that I am using here is not the angle that I am given at the start, but it is instead the unit circle theta that I can actually work with, that I actually have information about. What is cosine of 135? Positive or negative? Negative, because we are in quadrant 2. And so we end up with this square root of, it's a bit of a mess, but 1 minus root 2 over 2, all divided by 2. We could clean this up a little bit more, and in doing so, this would be like plus or minus the square root of 2 minus root 2 all over 4, something along those lines. But also, I'm perfectly fine with us just leaving things kind of unsimplified as is. Now, what's the thing that we haven't really resolved yet? The plus or minus. Okay, so is this going to be a positive value or is this going to be a negative value? That is going to come from the quadrant of the angle that we are actually taking the trig function. So looking at 67.5, what do I know? Where does 67.5 go? Quadrant 1, and cosine of a quadrant 1 angle is going to be positive. And so since this is in Q1, this is just going to be the positive version of what we see. And so to communicate that, we'll just erase this. All right, questions with our example? Okay. Let's take a look at example 6. This one's the sine one. So this is sine of 11 pi over 12. 11 pi over 12, is this, do we know this from the unit circle at all? No. Would we be able to decompose this into the sum of two angles that we know? Actually, probably, yeah. We probably would be able to use that approach. If you set the first angle to be pi over 4, this is like pi over 4 plus like 2 pi over 3. Subtracting the 3 pi over 12 from both sides. 8 pi over 12 would be that beta. So we could approach this using our sum and difference. That would be totally fine. But let's try approaching it instead with our kind of half angle here. How can I write 11 pi over 12 as an angle that I know divided in half? What is my theta going to be here? No, that's not writing it as an angle that I know divided in half. No, no. What's double Yeah, what's double 11 pi over 12? Well, that's going to be 11 pi over 6. And we're taking this and we are dividing it by 2, multiplying 2 into the denominator. Right? 11 pi over 12 is half of 11 pi over 6. The denominator is twice as large, therefore the value is half. Sine, this is going to be plus or minus the square root of 1 minus cosine of 11 pi over 6, all divided by 2. What is cosine of 11 pi over 6? Pi over 6 reference angle? Root 3 over 2, positive or negative? Positive, because we are in the fourth quadrant, all divided by 2. And again, I am perfectly happy with just kind of leaving this as is. What's the only thing that we haven't resolved yet? Plus or minus. 11 pi over 12 lives where? What is this close to? 11 over 12 is really close to 1, but is it a little bit more or a little bit less? A little bit less. So where does this live? Second quadrant. 11 pi over 12 is a little bit less than pi, a little bit less than 12 pi over 12. So this is a second quadrant angle. And what do I know about sine of second quadrant angles? They are positive. All right, questions with either 4 or 6? No questions, feels fine. It's a formula, you plug things into the formula. Okay. Let's take a look at number 8. For number 8, we are told that sine of theta is equal to negative 12 over 13, where theta is between 3 pi over 2 and 2 pi. If theta is between 3 pi over 2 and 2 pi, what do we know about theta? Quadrant 4, very good. Which makes sense, that sine of that theta would be a negative value. In this case, we are being asked to find tangent of theta over 2. Okay, we have a lot of options with which formula to use with tangent of theta over 2. You can use any of them. They're all the same. All of that is perfectly fine. I'm going to do the one that's literally sine of theta over 2 over cosine of theta over 2. That would be our square root of 1 minus cosine over 1 plus cosine. Plus or minus? But you certainly can do any of the others and you'll get the same result. Okay. So sine of theta equals negative 12 over 13. What does that tell us? Very good. So opposite side is 12, hypotenuse is 13, and therefore our adjacent side is, what do we say? 5. If we didn't know that, how could we figure it out? Pythagorean theorem. All right, so what is cosine of theta going to be, since that's really the only one we need here? 5 over 13, positive or negative? Positive, because what quadrant is theta in? Quadrant 4, where cosine is positive. So tangent of theta over 2 is equal to plus or minus the square root of 1 minus 5 over 13 over 1 plus 5 over 13. Which I would be fine leaving as is. Pearson and the corresponding 5.3 through 5.5 work that I'm having you do will not be quite as happy with just leaving that as it is. So rewriting the 1s as 13 over 13s, I get that this is plus or minus the square root of 8 over 13 over 18 over 13. The 13s here will cancel, but you can multiply by the reciprocal if you want to figure that, if you want to see that for yourself. This is plus or minus the square root of 8 over 18 plus or minus the square root of 4 over 9, which actually works itself out pretty nicely. This is plus or minus 2/3. So what's the only thing I'm missing here? Plus or minus. Okay, what did I use before to resolve the plus or minus? Yeah, we had to figure out what quadrant the actual angle that we're taking a trig function of lives in. So we need to know where theta over 2 lives. Do this in red here. Theta over 2. Now, if theta is bound above means that there's a number that sits above it that it's never able to kind of pass here. If it's bound above by 2 pi, it's never going to get more than 2 pi, then half of theta is never going to be more than what value? Than pi, which was just dividing that upper bound by 2, just like how we divided our theta by 2. Well, if our lower bound, the value that we're never going to be lower than, is 3 pi over 2, how could I find the lower bound for half of theta? Well, it should be half of that lower bound. The smallest that we can get for theta is 3 pi over 2. Then the smallest that we can get for half of theta should be half of 3 pi over 2. Which you can do out the division yourself. This ends up being 3 pi over 4. Okay, so theta over 2 sits between 3 pi over 4 and pi. Where is that? What quadrant does that represent? Second quadrant, very good. Pi over 2 and pi are second quadrant angles. Our theta over 2 must live between those. What do we know about tangent in the second quadrant? It is negative, and so we are going to be negative 2 over 3. Yeah, Simran. So So we found the quadrants to figure out, to resolve the positive negative, to figure out, like if I know that I'm in quadrant 2, then if I'm taking tangent. We're not done yet, guys. We're answering a question. We should probably listen. So how do we determine the quadrant, essentially? So this is a technique that we are actually going to see more of. So again, this might be a smart one to pay attention to, because we'll see this a lot on, say, Monday and Tuesday. If we want to adjust the minimum and maximum value for a particular angle, so let's say we are told that our theta here has to live in between two values here, then the adjustment is actually fairly easy when we're looking at what, say, theta over 2 must sit between. We just do whatever we did to theta to this new value here. So essentially, to go from theta to theta over 2, we divided by 2. So we're going to divide the upper bound by 2. We're going to divide the lower bound by 2. What we are going to see is we're going to make similar adjustments on theta, but instead of looking at theta, we'll be told, hey, maybe theta has to live between 0 and 2 pi. But we want to know what's going on with 5 theta. Well, if theta lives between